Hello guys, this is Batuhan from Maker, and in today's video I'll show you how you can transcribe your audios and videos and how you can translate those into another languages. Okay, first of all, we need to choose our file. We can go with video or audio, but it can be maximum 25 megabytes since it's the limit of Whisper API. Okay, let's first choose our file. We can get this episode 1 here, and also we can provide a prompt to improve our transcription. Sometimes you may say some brand names, some technologies, and etc. And if the Whisper API doesn't know about these names, it can be wrong. The transcription can be wrong. But if you provide these names with prompt, it will improve your transcription. For example, in this episode 1, I say something like Maker, Batuhan, it's my name, Next.js, TypeScript, Rectus, Tailwind, and etc. If I provide those keywords with the prompt, I can improve the transcription. Okay, and also we can choose the response type. We can go with VTT or SRT. Okay, I will choose the first one for this demo. And we can click this transcribe button. And as you can see, now we have our transcription with the timestamps. I think it's great. And as you can see, we can calculate our total token size, and then we can translate these transcription, these captions into another language with this click. But first, let's choose a language for us. Maybe we can go with Japanese here, and we can say translate to our API, and it will translate these captions into Japanese for us. Now we can download this transcription file with this button. As you can see, we have our transcription as VTT file in here. Okay, now if you are ready, let's dive into this application, and I'll show you how we can build these kind of applications with Next.js and OpenAI's Whisper API. First, let's check what we have here. As you can see in our page TSX file, we have this text and the transcribe component. Okay, in this transcribe component, we show different forms based on the form state. If the state is transcribe, we will show the form. If our transcription is ready, we will show another form. I will dive into this state and where we get this state in the next sections. Okay, but let's check the first form first. Okay, in here we have this simple form component, and when we submit this form, we call our submit handler. We create this submit handler in the atoms folder. We use Jotai for this application, and we can create asynchronous handlers with Jotai. I will dive into this part in the next section, but first let's check what we have as the form component. Okay, cool. And in this form we have our input for file. In this file we can accept audio or video, but it can be maximum 25 megabytes, so we can declare it in here as max prop. Okay, and the name should be file because we will send this form data to the Whisper API. That's why we need to have proper names. The name is important. Okay, it should be file. And then with the onChange callback function, we need to set file name, because in the next form we will download this file and we need to set its name, right? That's why we need to set file name into our state. Okay, cool. And the second input is prompt. Name is prompt. Again, it's important. It should be prompt like this. Okay? And we can accept text value for this input. Okay? Cool. And the final input is response format. Okay? And the name should be like this. We can go with this one or this one. Okay? These are important because these are the values which are accepted by OpenAI's Whisper API. Okay? Cool. And finally, if all the things are ready, we can call our submit handler with this button like this. Okay? So let's go to our atoms folder where we hold our whole state. Okay? Cool. Now we can go to our project folder and we can go to our atoms folder, and in this folder we have this transcription atoms. Okay? And first atoms is for transcription process and the second atoms for the translation process. But first we need to dive into this part, right? Okay, cool. And first we hold our file name in an atom and the file type like this, and also we hold our form data like this. Okay? And after we get our response from our API, we have this transcription atom where we hold our transcription text. Okay? Also, we have this handling atom to show user it's handling or not. And also, we have this form state atom. You remember that we were showing different forms based on this form state, right? If it's transcribe, we will show this form. If it's not transcribe, we will show this transcription edit form. Okay? And we can calculate this state based on the transcription. First, in this atom, we can get the transcription text like this. Okay? You can get others atoms value like this. You can use this helper function, get function, to get the data. Okay? And then if there is transcription, we will return translate as form state. If it's not, we will return transcribe. Okay? And finally, we create our transcription handler atom. In this atom, we will use asynchronous logic to get our transcription data from our API. To create atoms like that, you can use this format. First of all, you can pass null for the first value because this is gather like this. You can define your callback function to get data from another atoms. These kind of atoms are read-only atoms. Okay, you can get another atom's data and return as state. And if you create a setter atom like this, you need to use second argument. Okay, for the first argument we will use null, and for the second argument we will use this callback function. And in this function we can get our get helper function or set, or we can get the argument that we pass into this function like this, form data. We will pass this argument into this function when we call this function. Okay? And with these helpers we can get or set data in this callback. Okay? First we need to set our handling atom to true because we are starting our process, right? And then we can make a request to our API like this, and we will send our form data. If there's data, we will continue our process. If there is no data, we will throw a new error. Okay, cool. And once we get our data, we can set our transcription atom like this. When we set our transcription data, we will change this form state atom as well. You don't need to use any use effect. Jotai will synchronize those states for you. Okay, if there's transcription, it will run this logic again and it will change this state for you. Okay, cool. And finally, we will set our handling atom to false, and if there's any error, we will throw this error like that. Okay, cool. Now we can dive into our root handler, which is API/transcribe. Okay, now we can go to our root handler. In this API folder, we have another folder called Transcribe, and in this folder we have this root handler. Okay, it's a post request, and we get our form data from the request like this. Okay, and the form data should include file, model, response format, prompt like this, and if you want to send it, you can send the language data. Okay, that's why we need to append our model like this. We will use Whisper 1 model. Okay, cool. And finally, we can make a request to our OpenAI API like this: v1/audio/transcriptions, and we will pass our form data. If you don't have Axios, you need to first install this Axios library, but you can also use fetch in here. Okay, and when you send your form data, the last thing you need to do is setting your OpenAI API key. You can get this key from your OpenAI account. Okay, I will put this link into description and into video. Cool. When you send this form data to the API with your OpenAI API key, you will get response, and you can return this response like this. Okay, cool. Now let's try to make a request to our API. Let's choose this episode 2 for now, and we can put our keywords and we can hit transcribe button like this. Okie dokie. As you can see, our transcription is ready now. Cool, right? Okay, now we will dive into second part, how we can edit or how we can translate this transcription, and also how we can download as a file. Okay, now we can dive into second part, how we can edit, how we can calculate token size, and also how we can translate our transcription. First of all, you can edit this file like this. It's pretty easy. It's just a text component, text area component. But the tricky part is calculating token size, because we need to be in the limit of max token size, right? So let me show you. Let's copy this text and paste into here like this. As you can see now, it says that you are in the limit of token size. However, when you include the response, multiplying current token size with 2, okay, the token size will be exceeded. So we need to create this logic to calculate token size, because in the end of the day, we have this number as a max token size, right? So let me get rid of this unnecessary texts. Okay, cool. And finally, we will dive into this part, how we can translate our transcription into another languages. Okay, cool. First, let's start with the UI. We can go to our page folder, page file, and transcribe. And now we are in the second form, right? We are not, our form state is no longer transcribe, it's translate at the moment. So we need to go this part, okay? As you can see, we have our states here, our handling state, file type, file name, our language, our transcription, our translate handler, and token size message. We will dive into this state part in the next section. But first, let's check what we have as UI here, okay? We have this form again, and for onSubmit callback, we pass our translate handler, okay? Cool. But first, we check our token size message, and the type is success. We can call this translate handler. Otherwise, we will return, okay? Cool. And for the first input, we have this text area input. And with the onChange callback function, we can set our transcription like this, okay? Cool. And also, we have this token size message div. We change our colors based on the type of token size message. If it's success, it's green. If it's warning, yellow and red, and etc. We also show our token size message here. And finally, we have this select to change our language, the target language, right? So it's initially Spanish, but you can choose another language. You can translate into any language with the GPT 3.5 Turbo model, okay? Cool. And finally, we have these two buttons. We can run our submit handler with the button, translate button, or we can try to download our transcription as file, okay? Cool. Now we can dive into state part, and we can check how we create our logic with Jotai in the state part, okay? Cool. Okie dokie. Now we can go to our atoms folder again, and in this folder, now we will dive into translate part, okay? Cool. First of all, we need to get our target language with this atom, language atom. It's initially Spanish, but we can change this with the select, right? And also, we need to create a message atom, okay? Because we are using chat completion API here, and we send our data as message. This is the same API that ChatGPT use, okay? So we need to create our message atom, and this is a read-only atom. We will get our data with this helper function. First, we will get our transcription, and then we will get our language, okay? The first one is a system prompt. In this prompt, we set the mission of this AI instance. For example, we say that you are a translator machine. Your mission is translating these files into the language provided. Do not change the format of the file, only return the translated file. You can fine-tune this message, okay? You can write based on your needs of your application, okay? And the second message is the language and transcription. Please translate this file into language that we set here, okay? And the file is the transcription, this file, okay? Cool. And then we need to create our token size atom. In this atom, we write our logic to calculate our token size, okay? Cool. In this atom, first we need to define our max token size. It's like this, 4,000 96. Okay, this is the token size limit of this model. And then we need to get our messages from the messages atom, and we can calculate our current token size with this tokenizer. But first we need to install this library GPT-tokenizer, and also we need to set our model name like this. Okay, tokenizer.model name equals GPT-3.5 turbo. If you want to use GPT-4, for example, you need to set your model name like this. Okay, cool. Once you set your model name, you can use this helper function encode chat. Okay, the only thing you need to do is sending your message like this, and also you can set your model here again, but we have already set here, that's why we don't need to set again. And this helper function returns an array for you, and the array contains all tokens, so you can calculate the length of array and it will give you the token size of current message. Okay, cool. This is our current token size, and then we can calculate our remaining token size like this. We can subtract our current token size from the max token size, and finally we can return this object: max token size, current token size, remaining token size, and we can return this boolean: is token size exceeded? And there's another helper function here, is within token limit. Okay, you need to send your messages and your max token size as arguments with this helper function, and you can calculate if it's in token size or not. And also we need to calculate this boolean: can token size be exceeded? Which means that we need to calculate this. For example, we are sending this transcription file, but we also expect to get our response, right? This max token size includes request and response, so we need to calculate the response as well. That's why we want to multiply by 2 our current token size, because we sending these texts, we expect the get same size of token when we translate this into another language. But actually it's an estimation. Sometimes you may get decreased token size or increased token size. It depends on the language what you want to translate, right? But I didn't want to make it complicated, this part. That's why I simply multiply by 2 here, so we can calculate our real token size like this. Okay, and also we have this token size message atom here, and if there's a warning, we can send a warning message. If there's an error, it means that we exceeded our token size, and the warning means that we can exceed our token size when we add the response. Okay, and the success is we are good to go. We are in the token size limit. Okay, cool. And finally, we have this translate handler atom. This is the same logic with the transcription handler atom. In this atom, first we pass null value because we don't want to get anything, but we need to define our setter function here, okay? And we can make this an asynchronous function. We can use our helper functions get and set here. First, we need to get our messages, and we can send our messages and our max tokens with the token size atom, okay? We can get the remaining token size from there, and we can send to our API. And this is a stream. We will stream our responses in here. That's why we need to create different logic than the previous one, okay? We were not streaming the response here, but in here we are streaming the response, right? For example, if we choose German here and hit translate, as you can see, we are streaming the response, right? So we need to create a logic for that purpose. And I will show you how you can create in the next section. Okay, first let's check our root handler, this API root handler, okay? And then we can continue from here. Let's go to our API folder and the translate and the root, okay? In here, we will get our body from our request object like this, and we will get our max tokens and messages, okay? And we will use our GPT 3.5 turbo model, and we will send our messages and max tokens like this. And we need to set stream true here, okay? But as you can see, we have another helper function for streaming OpenAI responses, okay? Let's go check what we have here. So with this function, we will make a request to OpenAI API endpoint, and we stream the response instead of waiting for the finish, okay? So first of all, we need to create our encoder and decoder like this, and also we need to install this library, event source parser, and we will get our parsed event, reconnect interval, and create parser, okay? Cool. And initially we need to set our counter 0 like this, and then we will make a request in here to this API endpoint. We are using chat completions here, okay? And also we need to set our OpenAI API key here as well. And then we will set our method, and also we will send our data within body like this. Our model, message, max tokens, temperature, and streaming true. Okay, cool. And first let's check the response, and if it's not okay, we will throw an error here. And then we will create our stream with the readable stream API, okay? And we will pass our handler function here, and we will create our own parse callback function, okay? Cool. And then we will check our event type. If it's event, we will get our data from the event data. If it's done, we will close this request and return, okay? If it's not done, we will try to parse our data first with this JSON parse function, and we will get our text from the choices, okay? Because OpenAI will send some choices to us, okay? We will get the first choice from the response data. If it's empty string like this, we will do nothing and return, and then we will put our text, but first we need to encode it, and we will put our encoded text into the queue like this, okay? Cool. And finally, we will create our parser like this, and we will create our for loop, and for every chunk, we will decode our chunk and feed into the parser. And finally, we will return our stream. So it can be complicated when you check this piece of code like this, but as far as I know, Vercel is currently working on a better solution for this logic, because everybody use this piece of code and copy and paste from another projects, but I think that they are creating a library, brand new library, to make this process much more easier. So it means that, yeah, you don't need to dive into this code, but I think that it would be better if you understand how it works behind the scene, okay? And then we can go to our Atom again, and in here we make a request our API route like this, and we send our data within body like this, and again we will check our response. If it's not okay, we will throw an error here, and then we will get our data from response body, and if there is no data, we will throw an error here, and then we will create our reader like this, okay, and we will create our decoder like this, okay, cool. And initially the done state will be false, and we will set our transcription text as empty string first, because we need to clear the transcription first before we are starting to streaming our translated transcription, right? And we will create our while loop here, because with the stream we will get chunks as we get response from OpenAI, right? So we can create a while loop, and we can deconstruct this object. We can use our reader to read our data, right? And we can deconstruct this value and the state. If it's done, we will set our done to true, and we will stop our loop, okay, cool. And we will get our chunk value and decode it, and then we will set our transcription atom like this. We need to combine latest chunk with the previous chunks, right? And we will catch if there is error, and finally we will set our handling atom to false like this. If we can try this one, maybe we can translate into Turkish this time. As you can see, it started to streaming the response, the translated transcription. Okay, cool. And the latest part is creating this download button here. To understand how we can download this file, we can go to our let me check transcription edit form, and in here we have this download handler. Okay, first we need to create this blob with the transcription text, and the type will be text plain, and we will create an URL for this object, this blob object. Okay, we can create this URL with the window object and this helper function create object URL. Okay, and also we will create an element here within our document like this, and this is going to be a link element, and also we will set our download based on this URL. We will set our file name and the type like this. Okay, we will get our file name and split it because we don't want to use the extension from file name. Okay, we don't want to use MP3 or MP4 because we will use our own file type that we have selected in the first form, right? And then we will pass our URL as refprop, and then we will click this button with this handler. Let's click it here, and as you can see, we download this transcription file like this. Okay, cool. So thank you for watching this video, guys. I hope that you will find this valuable for your future projects, and if you want to see videos like this, please subscribe my channel, and if you like this video, please hit the like button.